Good morning, fourth graders. It's Mrs. Evans here. I'm ready for Math Day 2 on our YouTube channel. We're going to start out with a couple of reminders. Make sure that you're prepared for math this morning by having out your arithmetic book, a pencil, and your yellow spiral if you need it. Another reminder that's something new for us. If you come across any questions, don't forget, we have our question sheet that we're making. Any questions that you have, put the question on one side and we'll answer it on the other. Or you can just circle a problem in your book and ask me during our conference call. Let's start out with a game. We're going to play Beat the Teach with some different cards today. So all of the cards that you're going to see today are improper fractions. They're improper because the larger number is on top, the smaller number is on the bottom. You're going to throw that top number in jail and divide by the bottom number. You'll either get a whole number or you'll get a mixed number. Here we go. Your goal is to beat me. 2, 8 and 2 ninths, 5 and 3 sevenths, 4 and 4 fifths, 4 and 1 sixth, 9 and 1 sixth, 5, 4. This is just for the girls this time. 3, boys. 3 and 3 fourths. Everybody. 2. Good job. Yesterday, I introduced a new concept, and let's take a moment to review that. And as a matter of fact, today's lesson is just that, review of that previous concept from yesterday. Yesterday, I introduced to you KCF. Keep, change, flip. That's what we're going to use when we're dividing fractions. But I also told you yesterday that I would tell you the second version to our poem. Well, now is the time I'm going to tell you. You've been waiting all night so patiently. So you already know the first verse. Say that with me. Multiplying fractions is no problem. Top times top, bottom times bottom. Here's the second verse. You ready? Are you sure? Okay, here we go. When dividing fractions, don't ask why. Flip the second and multiply. I'll say that again. When dividing fractions, don't ask why. Flip the second and multiply. That's the second verse of our poem. So I hope you like that. Okay, let's start reviewing KCF. Here we go. Keep, but remember, the rule stays the same. We can only divide a fraction by a fraction. If you don't have one, we make one by putting a fraction bar and a 1 underneath that. Now that I have a fraction and a fraction, let's do our rules. I'm going to keep this one just the way it is, 3 over 1. I will change my sign from division to multiplication. Finally, I will flip the final fraction. 3 fourths becomes 4 thirds. Now, since this is day 2, I'm going to add in a little something extra. If this were a regular multiplying problem, what would I say is a fraction's best friend? If you answer cancellation, good job. I'm going to cancel if I can possibly do that because it'll make it so much easier. The 3's, I will divide them by 3. 3 divided by 3 is 1. 3 divided by 3 is 1. Go back to our verse 1. Multiplying fractions is no problem. Top times top. What is 1 times 4? 4. Bottom times bottom. What is 1 times 1? 1. Let's examine this. Is it proper? No, ma'am, it's not. Let's throw that in the division house. Divide by 1. 4 is our final answer. Okay, so let's go ahead and take a look at our next problem. This is going to be in your book, section 2, letter A. It says 6 divided by 2. The first thing that we have to remember is we can only divide a fraction by a fraction. If we don't have one, we make one. Now we will divide. We call this technically the inversion method. Whenever you're taking a fraction and you're flipping it over, That word is called to invert, I-N-V-E-R-T. So technically, this is called the inversion method, but I think of it as KCF, okay? 6/1, I'm keeping that. Change your sign from division to multiplication. Finally, flip the final fraction, or invert, if you want to know that word. So 2/3 becomes 3/2. Now remember, what is a fraction's best friend? Cancellation. Look diagonally. The smaller number here is 2, so I want to see if I can divide the 6 by 2, and I can because it's even. 2 divided by 2 is 1. 6 divided by 2 is 3. Multiplying fractions is no problem. Top times top. 3 times 3 is 9. Bottom times bottom. 1 times 1 is 1. Let's examine that fraction. Is it proper? No. Let's put that in the division house. 9 divided by 1 is 9. I'm going to put a circle around it because we are done with that one. I am going to skip down to section 2, letter F, because this problem is a little different than the ones that we've done so far today and the ones that we've done yesterday. Let's look at this closely. We can only divide a fraction by a. We don't have one, so we make 1. Keep 5/1. Change our sign from division to multiplication. Flip the final fraction. 4/5 becomes 5/4. Well, we cannot cancel anything here because we have a 1 diagonally and we have counting order here. So we're just going to go ahead and multiply. 5 times 5 is 25. 1 times 4 is 4. Ooh, examine this one. It's improper, so we're going to need to throw that in jail. Just as a reminder, when I say if it's improper, what are we going to do with that? What we're doing in our mind is we're setting up a little division house, and we're putting 25 on the inside and 4 on the outside. How many 4s go into 2? None. How many 4s go into 25? 6. 6 times 4 is 24. Subtract, we get 1. Compare. Is 1 smaller than 4? Yes, it is. We don't have anything to bring down, so instead of bringing down, we're going to bring the 1 up. 1 becomes our numerator. 4 becomes our denominator. 6 1/4 is the final answer here. So when you finish with your dividing, don't forget to ask yourself, is this a proper fraction? If it's not, we know we need to divide, okay? We know we need to divide. Let's go to section 3, letter A. Section 3, letter A. It's a story problem. Let's take a look at that together. 3A says, Amelia bought 3 yards of material to sew aprons. If each apron requires 3/4 yards of material, how many aprons can she make? Hopefully you're solving this with the cubes method. Cubes, C, means to circle, so you circled your numbers, 3, and you circled your other number, 3/4. Now we need to box the keywords. The keyword here is actually each. We're taking all of that material and we're putting it into groups, and they're each going to have the same amount. Remember my Snicker bar from yesterday? I need to keep those pieces equal. Otherwise, my buddy Mrs. Roach might be frustrated with me. So what we're going to do is put a box around each, and that signifies to us that we are going to take the whole number 3 and put it into equal groups of 3/4. When you're putting something into groups, you are dividing. Now that we have our problem set up, let's remember our rules. We can only divide a fraction by a fraction. If we don't have one, we will make one. Let's do this the KCF way. Remember, it's not KFC, it's KCF. We're flipping those. 3/1, we're keeping that. Change your sign to times. Flip the final fraction. 3/4 becomes 4/3. A fraction's best friend is cancellation. We can cancel the 3's. They become 1's. 1 times 4 is 4. 1 times 1 is 1. It's improper. 4 divided by 1 is 4. And remember, students, with every story problem needs to end with not just a number, but also a label. What does that 4 represent? Does it represent 4 Starbuckses, 4 volleyballs? I don't know. Let's take a look at the question again. It says, how many what? Aprons. Aprons will be our label, and that's what you need to include in your book as you circle your answer. 4 aprons is our final answer. Now, let's take a look. I think we have time to do one more thing. Go down to section 4, letter A. This is practicing with our conversions. When we start with a conversion problem as a review, we always start by looking at the end of the problem. For section 4, letter A, we are looking for pounds. That means everything that we're working with must be pounds. If it is not pounds, that measurement must be converted or changed to that measurement. Here's how that will work. This is pounds here. This is pounds here. This is not pounds. I'm going to change it to pounds by putting a box. And 1, 2, 3 underneath. We always start from the top of the box and work down. A pound is huge. We measure elephants and trains and trucks. Larger to smaller. Larger to smaller, multiply is step number 1. Step number 2 is our special number. How many pounds, how many of the smaller pounds does it take to equal just 1 ton? If you answer 2,000, good job. If not, go ahead and erase and replace with the correct answer, 2,000. Step number 3 is when you start at the top of your box and work your way down the steps. 4 times 2,000. 4 times 2,000. Now, because the order of our factors does not matter in multiplication, I'm going to put the 2,000 on top. Anything times 0 equals 0. 0, 0, 0. 2 times 4 is 8. 8,000 is not our answer. 8,000 is what goes inside the box. Now, to find that final answer, we will solve going across the bottom. If you need to rewrite this so that you can see it a little bit better, you totally can. I'm going to do that underneath. 8,000 is my minuend. 356 is my subtrahend. Bigger bottom, better borrow. The only neighbor that we have is 8. 8 becomes a 7. The neighbor becomes a 10. We still need something. Go to our neighbor, make him a 9. The 10 goes there. We still need something. Borrow, 9, 10. We have enough. Let's subtract. Take 6 from 10, 4. 5 from 9, 4. 3 from 9, 6. Nothing from 7, 7. 7,644 is our answer, and that is exactly what we're going to put up at the top in our pound sections. Okay, here we go, just like this. 7,644 is our final answer. Okay, it's almost time for me to go for today, so here is your mission. Ready? Okay, your mission is to practice keep, change, flip on the front. On the back, that is all review, nothing new there. Do as much as you can. Circle what you have concerns about, and we'll discuss those during our FaceTime. Have a terrific Tuesday. I love you guys. I miss you, and I'll see you soon. Bye-bye.